Okay, so welcome to our fifth video in our series about logic and the CPU. Alright, so we're going to get straight into our presentation today. We're going to start with a few well dones. Okay, so these people all sent me some great work on creating their half adder and their full adder. So we're going to start with William. Well done to William, really well done. Okay, well done to PN as well. She did really well, made a real put a lot of effort into trying to get her half adder working. She couldn't quite manage it, but a lot of effort went into. Well done, PM. Okay, we missed a few out there. Let's have a look. Okay, so we've got Zoe as well. Well done to Zoe. She did some really great work as well. Well done to Amari. Okay, so we've got Amari here as well. And Jonan. Okay, so well done to all of those 5 people for making a real effort on their computer science work. So well done, you 5, and I really appreciate the amount of effort that's gone into that work. Okay, so really well done. Okay, so if we move on, all right. So last week or the week before last, sorry, we were off last week, weren't we? But so last week we were talking about how the CPU is made up of loads and loads of switches which are connected together using logic gates, okay, into a really complicated circuit. And that circuit and that combination of switches and logic gates is what creates the functionality. That's what makes your CPU do everything that it does. Okay, so and I asked you to go away and to have a go at creating some of those circuits and creating those circuits so that you could get your own CPU to perform some of that functionality. Okay, well, what we're going to talk about this week is we're going to talk about how the CPU works. So although the CPU is actually a really complicated circuit, it's quite a complicated thing, okay, actually the way it works and the way it operates is actually really simple, okay, and I'm going to explain that to you today. So hopefully by the end of the lesson you will understand what we're going to talk about, which is the fetch, decode, execute cycle. Alright, and you'll be able to describe the steps in the cycle. And hopefully, now the most important bit from this, actually, probably for most of you, is actually what you're going to learn about today will help you understand how computers work. Now, some of you might be thinking, well, I don't need to know how computers work, but actually what makes it really important is what you're going to learn today will allow you to compare computers, so that when you have to go to the shop and buy your own computer, all right, you'll be able to compare 2 different computers, and they will and what you're going to learn today will help you understand which one is better and which one will perform better. Okay, so we need to understand that actually the way the CPU works is actually really simple. All right, so it just does 3 instructions, and instruction number 1 is just that it fetches an instruction from main memory. Okay, so it fetches an instruction from main memory. Now, another name for main memory, and you might know it as this, is RAM. Okay, so it just fetches an instruction from RAM or main memory. Okay, next it decodes that instruction. So what do we mean by decodes? Well, the CPU needs to translate it into a language that it understands. Okay, so the likelihood is that that instruction that's stored in main memory is going to be stored in a format that the CPU won't understand. So what the CPU has to do is it has to translate it so that it knows what it has to do. Okay, so that's the decode part. All right, that's instruction number 2. Now, instruction number 3 is to execute that instruction. Okay, so once the CPU understands what the instruction is, it knows it's decoded it, and it knows what that instruction is, it then executes it. Okay, so it then executes the instruction, and that is it. Okay, that is the fetch, decode, execute cycle, and that is all your CPU does. Okay, it just repeats that cycle over and over again. Okay, so what I want you to do, I've just got a little video that I'm just going to show you, just to show you how that process works. Okay. All right, I apologize for the amateurish nature of my animation there, okay, but hopefully it showed you how the fetch, decode, execute cycle works. All right, what you saw was the CPU fetching instructions from main memory. Okay, that instruction was coming from main memory. It was being stored in the CPU. The CPU was then decoding it, and then it was executing it. Okay, and once that had happened, once it finished executing it, it just went back to instruction number 1 and fetched the next instruction. Okay, and it just repeated that process over and over and over again. Okay, now what blows my mind every time I think about it, okay, and maybe won't blow your mind, you'll have to wait and see, okay, but what blows my mind is that your CPU can do that millions, if not billions of times a second, okay, and it's just unbelievable, that for me. All right, and of course, the faster your computer can do this, the better the performance. All right, so the faster your computer can carry out that fetch, decode, execute cycle, the more times it can do that in a second, okay, the better the performance of your computer. Okay, now the amount of times your computer can do that in a second is known as the clock speed, and some of you might recognize the term clock speed. All right, because when you buy a CPU, the performance of a CPU is measured by its clock speed. Now, I went and did a little bit of research, okay, and I found out that the latest CPU, the i9 from Intel, has a clock speed of 5.3 gigahertz. Okay, so I've got a little challenge for you, and you know how this works. You've got to pause the video for about 30 seconds to a minute while you try and attempt my challenge. Okay, so my challenge is, can you find out for yourself what 5.3 gigahertz means? All right, I think I'm going to give you 2 minutes for that challenge, okay? So when I say go, make sure you pause your video, all right? Go. All right, so hopefully you've paused the video. What does 5.3 gigahertz mean? Okay, well, hopefully you found out that that is 5.3 billion cycles per second, okay? So that CPU, okay, is going at 5.3 billion cycles per second. And that just blows my mind to think about that. All right. Now I've got another challenge for you. Okay. So again, I'm going to ask you to pause the video. Can you think? So if you think about it, think about this. Okay. So you put your CPU in your computer, and it's operating at 5.3 billion cycles per second. All right. So it's going really, really fast. Okay. So can you think of a problem that this might cause? All right, and there's a photo there that might give you a little bit of a clue. All right, so again, I'm going to give you a minute just to think about that. All right, so when I say go, pause the video and just have a think. Can you think what the solution to my challenge might be? Okay, go. All right, so hopefully you were honest and paused for a minute. What do you think the problem might cause? All right, well, the picture hopefully tells you what it is. Okay, if you think about this, and I've been out exercising recently. Okay, and it turns out that the faster I go, the hotter I get. All right, well, that's it. So that's a problem that I have, but that's exactly the same problem that your computer has. Okay, the faster that CPU operates, the hotter it gets. All right, and that means that computer designers have to spend a long time trying to think about how are they going to keep your computer cool, how are they going to keep that CPU cool. All right, now that makes me think of another interesting question for you, and I'll get you to pause the video again. All right, maybe you can think of what might be the difference between the CPUs that you find in a laptop compared to the CPUs that you find in a desktop. All right, so again, have a think about that. I'm going to ask you to pause for when I say go, and have a think. What can you think might be the difference between a CPU that you find in a laptop and the CPU that you find in a desktop? Okay, so have a think. Go. All right, so again, hopefully you were honest and you did pause the video. All right, well, let's think about this. We've just discussed the idea that the faster that a processor runs, the hotter it gets. Okay, and that means that people then have to spend time thinking about how they're going to cool the CPU down so it doesn't get too hot. Okay, well, if you think about it, in a desktop, that's really, really easy to do because you've got lots and lots of room in a desktop computer. All right, so you can put really big fans in, all right, and you can make it really, really easy to cool the CPU. Now, do you have that privilege, that much space in a laptop? Okay, no, you don't. So you can't put as powerful a CPU in a laptop because it would just get far too hot. All right, and so when you compare a desktop and a laptop, you should find that desktops have far higher performing CPUs in than laptops do. Okay, so let's move on. There we go. There's the solution to that one. That's what we just talked about. Okay. So the other part of the fetch, decode, execute cycle that we talked about, all right, was main memory or RAM. Now we talked about RAM a few weeks ago when we talked about different types of storage. Okay, and RAM is really important in the fetch, decode, execute cycle. Okay, and the reason why it's really important is because instructions are fetched from it. So the CPU retrieves all of the instructions that tell it what to do from RAM. Okay, so I've got another challenge for you, so I'm going to ask you to pause again. I know it's been lots of pausing, okay, but have a think about this. So you've just learned some information about the CPU. Okay, we've just talked about the CPU and how fast it runs. So I want you to think, now you know that information about the CPU, can you tell me anything about RAM? Can you think about what impact what you know about the CPU might mean for the RAM? Okay, so again, when I say go, give yourself a minute to have a think about that. All right, go. Okay, well, hopefully you've had a think about that. Okay, so what we've talked about is the fact that the CPU is really fast. Okay, now what we don't want the CPU doing is it waiting around to get data from memory. All right, we don't want it to be, there's no point in it sitting around doing nothing. All right, so that means that the RAM has to be really quick at retrieving data. All right, because if it was slow at retrieving data, the CPU would just be waiting, and that would be pointless. Okay, and it wouldn't be worth your while. Okay, so the RAM has to be really quick, and it has to be able to retrieve data really fast. Okay, and I say it's the Usain Bolt of memory. Okay, so RAM is the Usain Bolt of memory. It's the fastest type of memory that you will find. Well, actually, I'm going to put a little thing in there because you might find, well, no, it is the fastest type of memory that you'll find, but you're going to find out a little bit more in the extension activity. Okay, now, the more RAM you have, now let's have a think about this. If you think about this, the more RAM you have, the more instructions that you can store in it. Okay, so the more instructions you can store in it, the faster they can be retrieved by the CPU. Okay, so that means that a computer that has more RAM will perform better than a computer with a smaller amount of RAM. Okay, so RAM is actually really important to the performance of a computer, and people with more RAM will find that their computers run much better than people with only a small amount of RAM. Okay, so that's worth keeping in mind when you're thinking about buying your own computer system. Okay, so this is your task for this week. So I've uploaded a sheet to show my homework for you, and what I want you to go away and do is I want you to go and find out about the CPUs and the RAM that you find in popular computer systems. Okay, so for example, you're going to go and find out how much RAM and what type of CPU is in the iPhone and the iPad, and some popular laptops and desktops. Okay, so because it's really important to understand what type of CPU is in there and how much RAM is in there, because that will tell you about the performance, and that will allow you to compare different computer systems. So what I want you to do, once you've completed the table and once you've found out about the amount of RAM and the CPU, I want you then to rank them, to put them in order. So you're going to put those computer systems in order from the least powerful to the most powerful, okay, because that's really important. Now there's also an extension activity this week. Okay, so this is the extension activity for this week, and so this is the extension activity. So to make a system even faster, most CPUs come with something called cache. All right, and so for those people that have time to do the extension activity, what I want you to do is see what you can find out about cache, and and I want you to be able to tell me what you can find out about how it improves the performance of a computer system. Okay, so that's it from me. It's been hopefully this has all made sense. Okay, don't forget the live lesson. All right, so my live lesson is at 1:40, and I will see you there. Thank you very much.